Hello students, we continue our lecture series on rotational dynamics, and today's lecture is on again moment of inertia. We found moment of inertia in some cases of extended bodies. We found moment of inertia of rigid bodies, of discrete bodies, and sometimes we need to use calculus that I did in many cases, like moment of inertia of a rod, moment of inertia of a disk, moment of inertia of a ring, moment of inertia of a sphere, of course about the center of mass axis, about the axis passing through the center of mass. In case of a rod, I found moment of inertia about the center of mass, also about the edge line, an axis passing through one of the ends of the rods. That was 1/3 ml square. Okay, now in order to avoid this calculus, we will learn two theorems on moment of inertia: parallel axis theorem and perpendicular axis theorem. And these two theorems will help us to find moment of inertia in more cases where जहाँ हमें calculus लगाना हो, वहाँ हम ये theorems use करके हम moment of inertia निकाल सकते हैं. ये two theorems जो है, ये दो theorems, these parallel axis theorem और perpendicular axis theorem, ये बहुत ही important है in rotational dynamics. So we will do them and with applications. First we will try to understand the theorems and then we will apply them in real-time cases. So first, parallel axis theorem. Parallel axis theorem, ये पहला theorem है. ये theorem apply करने से हमें moment of inertia हम determine कर सकते हैं in most of the cases. तो क्या है theorem? अगर हमारे पास कोई बॉडी है, रिजिड बॉडी हो या कोई प्लेनर बॉडी हो या रिजिड बॉडी हो, 3 डायमेंशनल हो या 2 डायमेंशनल, एनी बॉडी, इसका कोई सेंटर ऑफ मास तो होगा. अगर एक एक्सिस पास करता है थ्रू द सेंटर ऑफ मास, तो इस रिजिड बॉडी का मोमेंट ऑफ इनर्शिया इस सेंटर ऑफ मास एक्सिस के अबाउट समझो IC है. मोमेंट ऑफ इनर्शिया ऑफ द रिजिड बॉडी अबाउट द सेंटर ऑफ मास एक्सिस IC. And we know, in most of the cases, we know this moment of inertia of rigid bodies about the center of mass axis. In most of the cases. Now, we want to find moment of inertia of this rigid body, the same rigid body. Not about the center of mass axis, but about some another axis. The new axis may be outside the body, it may be even inside the body. This new axis, it may be inside the body, or it may be even outside the body. That is immaterial. Maybe it is here, maybe it is outside. But the new axis is parallel to this center of mass axis. अगर ये parallel है, तो इन दो का जो distance है वो define किया जा सकता है. Suppose it is h. That is why it's called parallel axis theorem. The new axis is parallel to the center of mass axis. Suppose the moment of inertia about this new axis is I. If you know this IC already, you can find this I. It can be derived in a moment or it can be proved. This theorem can be proved, but we don't need that because this is a lecture for NEET aspirants or even IIT aspirants. I want to write this, what is I in terms of IC. The answer is I, the moment of inertia about the new axis is equal to IC plus mass of the body, that is mh square. This is the answer. The moment of inertia of the new axis, which is parallel to the center of mass axis, is moment of inertia about the center of mass axis plus mass of the body into h square, where h is the distance between the two axes, because the two axes are parallel, and this h can be defined. That's all. Suppose sometimes you know the moment of inertia about this axis, this one. Then you can find moment of inertia about the center of mass axis. So I mean, either this should be, if this is known, this can be found. If this is known, this can be found. So this is a very important theorem. So this is parallel axis theorem. Parallel axis theorem. इससे हमें यह भी पता चला ये जो मोमेंट ऑफ इनर्शिया अबाउट द सेंटर ऑफ मास एक्सिस है, अबाउट मोमेंट ऑफ इनर्शिया अबाउट एनी एक्सिस इज मोमेंट ऑफ इनर्शिया अबाउट द सेंटर ऑफ मास एक्सिस प्लस mh स्क्वायर प्लस समथिंग लाइक mh स्क्वायर। इसका मतलब मोमेंट ऑफ इनर्शिया अबाउट द सेंटर ऑफ मास एक्सिस इज मिनिमम, अबाउट एनी अदर एक्सिस it is more. So IC is minimum for the bodies. Moment of inertia about the center of mass axis is minimum, right? Okay, well that's all. This is the parallel axis theorem. If you have axis passing through the center of mass, you can find the moment of inertia about any axis, new axis which is parallel to this center of mass axis, provided you know the distance between the two axes and you know the mass of the body. That's all. Okay, now let me go to the applications. How it is applied, why it is applied, why it gives you benefit. जहां पर आपको कैलकुलस का यूज करना है वहां आप ये थ्योरम यूज करके उसको आंसर निकाल सकते हैं. So let us apply the case, this theorem in simple cases. Second, applications. Suppose मेरे पास ये रिंग है, you know this is center of mass and this axis passing through the center of mass. There is that axis is perpendicular to the plane of the board. It is also perpendicular to the plane of the ring, but passes through this. What's the moment of inertia about this axis? But this axis and this axis, they are parallel. This line is also perpendicular to the plane of the board. Here also the line which passes through the center of mass, that also is perpendicular to the plane of the board. And distance between the two is, okay, suppose 2r. R is the distance, radius of the ring. This is axis here and this is also axis. O means a line out of the plane of the board. O means a line out of the plane of the board. So, what's the moment of inertia about this axis? Moment of inertia about the center of mass axis is given. So, I will write the formula. Moment of inertia about the new axis, that one is equal to IC plus mh square. That is I is equal to, what is IC for the ring? It is a ring. That is mr square. That's what we know. Already we have done that. It is m. What is h square? That is 2r whole square. So, I is equal to mr square plus 4mr square. That is I equal to 5mr square. Answer we have used. Otherwise, it was very difficult to find the moment of inertia about this axis if we don't use this theorem. Okay. Third one, application, second application. Second application. Second application. This was first one, second application. Suppose that it's a disk here, and I know the moment of inertia of the disk about the center of mass. But again, the center of mass axis perpendicular to the plane of the disk and also perpendicular to the plane of the board. So it is, I will write something like outward axis, out. So I make a hole here of the disk. Here is the hole, and I pass a needle through the hole. Let that be the axis. Here is a needle passing through the disk, perpendicular to the board. Let that needle be the axis. So what is the distance between this axis and this axis? Let me suppose, okay, r by 2. R by 2. What is the moment of inertia about this axis, this new axis? You know the moment of inertia about this axis. That's already we know. I is equal to IC plus mh square. I is equal to, what is IC? Moment of inertia about this axis, center of mass axis, perpendicular to the plane of the board, also the plane of the disk. That is 1 by 2 mr square plus m. What is h? Distance between the two axes, this one and this one. That is r by 2 and square of this because of h square. So it is I equal to 1 by 2 mr square plus 1 by 4 mr square. So I equal to, if you add them up, it is 3 mr square by 4 answer. If you add them up, you will get this answer. Third example, we are using the parallel axis theorem. We know the formula. Of course, I have not derived the, I have not proved the theorem. I have not derived this, but we can apply it anywhere we, anytime we like. Okay, now third example also. Let me give you third example. Third example. It's a ring here. It's a ring, and it's a ring here, and I have a needle beneath this periphery. What is the moment of inertia about this needle which is just beneath the periphery? ये समझो रिंग ऐसे है, मैंने इस रिंग को ऐसे इस पे रखा, किसी नीडल पर रखा रिंग, so the needle touches the periphery, something like this. I should have a ring. The ring is like this, and you have just a needle beneath the upper periphery of the ring. What is the moment of inertia of this ring about this axis? This is R, this is the axis, and this is the new axis. About this axis, you know the moment of inertia. Ring hai, so you know mr square, but the moment of inertia about this axis. So it is again I is equal to, okay, IC plus mh square, and I is equal to, what is IC? About this, that's mr square, that's what we know. mh square, m, what is h? Distance between the two axes, this one and this one. Both are perpendicular to the board, therefore they are parallel to each other, r square. So I is equal to 2 times mr square. Answer. Fourth example. Fourth example. Now see here, suppose it's a sphere. Yes, sphere hai. Solid sphere. You know the moment of inertia about the diameter axis. You know the moment of inertia of the diameter axis passing through the center of mass. I want to find the moment of inertia about this axis, new axis, which is a tangent to the sphere. This tangent axis hai. It is tangential to the sphere. About this axis, you know, IC, वो आपको पता है, that is 2 by 5 mr square. और ये डिस्टेंस जो है इस एक्सिस और इस एक्सिस में जो डिस्टेंस है, पैरेलल है दोनों, तो ये r है. So what is the moment of inertia about this axis? So that is I equal to IC plus mh square. That is I equal to, what is IC? That's 2 by 5 mr square plus m. What the distance between two axes? That is this h. Distance between the two parallel lines. That is r square. That is I equal to, if you solve this, that is 7 by 5 mr square. Answer. So this is all about what you call as parallel axis theorem. I have given you the few examples about parallel axis theorem. Now let me go to the perpendicular axis theorem. Perpendicular axis theorem. Perpendicular axis theorem. Perpendicular axis theorem. Third, perpendicular axis theorem. Perpendicular axis theorem. Perpendicular axis theorem is, suppose there's a planar body. There's a planar body and you locate the center of mass, and now 3 axes are passing through the center of mass. x-axis, y-axis and z-axis. X-axis, the planar body lies in the xy plane. It lies in the xy plane. And z-axis is perpendicular to the plane of the body, to the planar body or to the xy plane. Then what is perpendicular axis theorem? The perpendicular axis theorem states that moment of inertia about x-axis plus moment of inertia about y-axis is equal to moment of inertia about z-axis. Ix plus Iy is equal to Iz. Something like this. Have a look. I have this this is a body, planar body. It is the center of mass of the planar body. It is an x-axis. It is y-axis. So the planar body lies in what? In xy plane. The planar body lies in the xy plane. And this body must have some moment of inertia about x-axis. Suppose if we rotate this body about x-axis, the moment of inertia about x-axis will be involved. If we rotate this body about y-axis, then moment of inertia about y-axis will be involved. It must have some value about x-axis, the moment of inertia x-axis. It must have some value of moment of inertia about y-axis. Then z-axis is perpendicular to the xy plane. That is out of the board, like this. But we can make it just here by dotted line. That is z-axis, right? So what is the moment of inertia? So if we rotate it like this, if you rotate it in the plane of the board, so we'll be rotating it about the x-axis. अगर ये board पर ही rotate, अगर ये ऐसे rotate करती है, ऐसे rotate, so it is rotating about z-axis like this. Suppose it is my hand, it is my hand on the plane of the board. If it rotates like this, it rotates about x-axis. It can rotate about y-axis. Like this, it rotates about z-axis. Something like this. It is the planar body. Let me suppose it is a planar body. It is x-axis. It is y-axis. It is z-axis. If this body rotates like this, it rotates about x-axis. So it has moment of inertia about x-axis Ix. If it rotates like this, it rotates about y-axis. So it has moment of inertia about y-axis. If it rotates like this, like this. If it rotates like this, it is z-axis. If it rotates like this, like this, it rotates about z-axis. If it rotates like this, it rotates about x-axis. If it rotates like this, it rotates about y-axis. So it has moment of inertia about x-axis. It has moment of inertia about y-axis. It also has moment of inertia about z-axis. All may be different, but the rule is moment of inertia of this planar body which lies in the xy plane, Iz is equal to Ix plus Iy. That's all. This is called perpendicular axis theorem. But all the three axes must pass to the center of mass. So this is perpendicular axis theorem. Axis theorem. That's all. So let me apply this perpendicular axis theorem in some cases. Let me take the case, simple cases. First case, a ring. Let me take a ring. It is x-axis. It is y-axis. What is moment of inertia of this ring about x-axis? That we don't know. We know moment of inertia of the ring, of course, but about z-axis, because we know z-axis is perpendicular to the plane of the ring. That is mr square. But this x-axis, ये जो y-axis है और z-axis है, they are diameter axes. They pass through the plane of the ring, through the diameter, although they pass through the center of mass. This axis also passes through the diameter of the ring, also through the center of mass. But we don't know Ix and Iy of the ring. No, that we don't know. We know moment of inertia of this ring about the center of mass axis, but that center of mass axis passes through that center of mass axis is along the z-axis. I mean, that is perpendicular to the plane of the ring. This, about this axis, you know the answer. Not about this, not about this. So it is z-axis. So Iz, you know, that is mr square. Ring ka. But suppose you want to know what is moment of inertia about Ix. That means I diameter, because this passes through the diameter. It is Ix, Iy, but it is also diameter. Moment of inertia about this line and this line is the same because both are diameters. ऐसा आप नहीं कह सकते कि इसका मोमेंट ऑफ ये मोमेंट ऑफ इनर्शिया कुछ है तो ये डिफरेंट है. बोथ द लाइंस आर पासिंग थ्रू द डायमीटर ऑफ द रिंग. अगर ये लाइन ऐसे नहीं ऐसे होता तो सेम मोमेंट ऑफ इनर्शिया, बिकॉज डायमीटर तो डायमीटर है. whichever way you like, ऐसे करो या ऐसे करो, ऐसे करो. Okay, now what is Iz? Moment of inertia about z axis, that is Ix plus Iy as per the formula. So what is Iz? That is Id plus Id, because both are diameter axes. So what is Iz? That is mr square is equal to 2 times Id. So what is Id? 1 by 2 mr square. That is the answer. Now, if you want to know what is the moment of inertia of a ring about the diameter axis, any line passing through the diameter but in the plane of the ring, not perpendicular, in the plane of the ring, that is 1 by 2 mr square. So you have used a method, a good method, a good theorem to find your answer. Otherwise, it would have been a difficult problem using the calculus. Okay, second example. Second example. Second example. Second example. B. अगर ये डिस्क है, इट्स अ डिस्क, सेम पैटर्न, एग्जाम्पल का सेम पैटर्न है. ये एक्स एक्सिस है और ये वाई एक्सिस है. ये डायमीटर भी है, ये भी डायमीटर है, और ये जी एक्सिस है. लाइक दिस. I want to know the moment of inertia of a disk about diameter axis, not about the axis perpendicular to the plane of the ring. No, that I know. That is 1 by 2 mr square. About this axis, you know. I want to know about this axis. Use the same rule. Iz is equal to Ix plus Iy. What is moment of inertia about z axis? This. That is 1 by 2 mr square. What is Ix? That is Id plus Id. So that is 1 by 2 mr square. 2 times Id. What is Id? ये 2 यहाँ आएगा इधर. 1 by 4 mr square. So moment of inertia of a disk about diameter axis, can take diameter any line passing through the center of mass in the plane of the disk. That will be the diameter axis, and that is 1 by 4 mr square. तो अगर आप और एक एग्जांपल लेते हैं, मतलब यह मैं लेना चाहूंगा ये, you know, I will get one example where I use both. I want to use both these theorems in a single example. Let me see how it works. दोनों को परपेंडिकुलर एक्सिस थ्योरम और पैरेलल एक्सिस थ्योरम को मैं, दोनों थ्योरम्स को मैं एक ही क्वेश्चन में यूज करूंगा, एक ही प्रॉब्लम में यूज करूंगा. शायद उससे आपका थोड़ा सा और एक्सपीरियंस होगा इस चीज का. चलिए, सी एग्जाम्पल. चलो, ये मेरा डिस्क है, मुझे चाहिए मोमेंट ऑफ इनर्शिया अबाउट दिस टेंजेंट टू द डिस्क. बट फॉर दैट आई मस्ट नो मोमेंट ऑफ इनर्शिया अबाउट द डायमीटर एक्सिस. दिस, ये डिस्क है, लिखना चाहिए, बिकॉज देयर इज हार्डली एनी डिफरेंस बिटवीन डिस्क एंड द रिंग ऑन द बोर्ड. आई मेक दिस सेम वे बोथ, इसलिए मैंने यहां लिखा है डिस्क और रेडियस है r. तो ये डायमीटर एक्सिस है, ID, और ये नया एक्सिस है, दो एक्सिस आपस में पैरेलल है, लेकिन डायमीटर एक्सिस के जो डायमीटर एक्सिस है डिस्क का, उसका मोमेंट ऑफ इनर्शिया क्या है, अबाउट व्हाट द मोमेंट ऑफ इनर्शिया ऑफ द डिस्क अबाउट द डायमीटर एक्सिस, दैट इज नॉट 1/2 mr स्क्वायर, अभी हमने निकाला दैट इज 1/4 mr स्क्वायर। अब मुझे इस एक्सिस के अबाउट लेना है। नाउ यू कैन यूज पैरेलल एक्सिस थ्योरम, व्हाई, बिकॉज दिस एक्सिस एंड दिस एक्सिस आर पैरेलल। देख लो, ये एक्सिस और ये एक्सिस पैरेलल है, क्योंकि ये टेंजेंट टू द डिस्क है, कोई भी टेंजेंट टू द डिस्क ले लो वो डायमीटर को पैरेलल आ जाएगा। तो व्हाट इज मोमेंट ऑफ इनर्शिया अबाउट दिस टेंजेंशियल एक्सिस? सो I is equal to IC plus mh square. So I is equal to, what is IC? Moment of inertia about the center of mass axis. That is this, not this. That is 1/4 mr square plus m, ये h क्या है, ये भी r है, r square. That is I equal to 4, it is 5/4 mr square. खत्म हो गया। So you can find moment of inertia in most cases by using these two strong powerful theorems. Okay, one more example. चलो यहां पर और एक एग्जांपल मैं देना चाहूंगा। डी, मेरे पास ये रॉड है, ये सेंटर ऑफ मास एक्सिस है IC. What is the moment of inertia about the center of mass of the axis? What is the moment of inertia of the center of mass axis perpendicular to the rod and perpendicular to the rod? That is, if you remember it, 1/12 ml square. Now what is the moment of inertia about this axis passing through one of its ends? और ये तो है डिस्टेंस L/2, कैसे निकालेंगे? वैसे मैंने आपको ये कैलकुलेशन से दिया था, कैलकुलस से दिया था, इस लाइन का जो मोमेंट ऑफ इनर्शिया है वो दैट इज 1/3 ml square if you remember. But now let me use parallel axis here and let me see should I get the same answer or not. वो मैंने पहले आपको दिखाया था, कैलकुलस को यूज करके मैंने आपको ये दिखाया था कि मोमेंट ऑफ इनर्शिया अबाउट दिस लाइन, अबाउट दिस एंड एक्सिस पासिंग थ्रू वन ऑफ द एंड्स ऑफ द रॉड परपेंडिकुलर टू द लेंथ ऑफ द रॉड, ऑफ कोर्स ये मैंने अलग से दिखाया था आपको, एंड आवर आंसर वाज 1/3 ml स्क्वायर। तो यहां पर क्या करोगे आप, यहां पर है I is equal to IC प्लस mh स्क्वायर का फॉर्मूला यूज अगर हम करेंगे, दैट इज I इक्वल टू मोमेंट ऑफ इनर्शिया अबाउट दिस एक्सिस, सेंटर ऑफ मास एक्सिस के अबाउट क्या है 1/12 ml स्क्वायर प्लस m, व्हाट इज h, डिस्टेंस बिटवीन द टू एक्सिस, पैरेलल एक्सिस, दैट इज L/2 होल स्क्वायर, दैट इज I इक्वल टू 1/12 ml स्क्वायर प्लस m l स्क्वायर बाय 4। तो I इक्वल टू ये 12 LCM लेकर के 12 इट इज 1, it is 4, it is 3, it is 3, it will be 4 ऊपर by 12 ml square, that will be I equal to, that will be let me get it here, I equal to 1/12 ml square plus ml square by 4, that is I equal to, it will be 1/3 ml square, check it out, I won't be surprised if it's add करके ये 1/3 ml square का आंसर आएगा, because we already did it, हमने इसको पहले भी किया हुआ है कैलकुलस से, अब इससे भी यही आंसर आना चाहिए। So this was a very important topic about theorems, parallel axis theorem and perpendicular axis theorem. You do it and you do more examples on this, and you can get more questions from my application, Tantra Sir Physics classes. And also don't forget to subscribe to my channel, Tantra Sir Physics class. You will get all the lectures on physics course, 11th, 12th, and then entrance, NEET. Everything is available there. Thank you.